Hello and happy Father's Day from the Computer Science of Dentistry channel. In this video, I'm going to be showing you how it's possible to directly fabricate Essex-style appliances in Meshmixer. And I don't necessarily mean the model in which to then 3D print and then vacuum form or whatever the protocol you might have is. But I quite literally mean designing the appliance itself and then 3D printing that appliance out on its own. So kind of saving an entire step there. Some appliances in dentistry that I can think of that kind of use this idea of just a simple shell over the teeth would be let's see, bleach trays, indirect bonding trays. I guess is the same thing, but clear aligner attachment templates. Let's see, wax up matrices, Essex retainers, anything really like that. That's like just a simple shell that goes over an occlusal surface that intimately wraps around those surfaces. That also does not need to worry about like undercuts or removing undercuts or anything like that. Sometimes you don't really want to remove the undercuts. That seems to be a big thing right now in trying to get night guards and maybe certain dentures, custom trays. You really want to figure out where those undercuts are and try to make a model that's going to be appropriate for that indication. But like I just mentioned, there's several indications where you don't need to, and in fact you don't want to remove those undercuts. So that's what this is right now. And before we get too far, you're probably thinking, well, can you even do that? and as far as 3D printing these types of things, and the reality is I don't know. I don't think so, actually. Not aligners, not Essex retainers. Another one I forgot would be like soft night guards. But that type of resin isn't out yet, but I know it's just a moment away from coming down the pipeline. So this is one of those instances where the software technology is just a little bit further ahead of the 3D printing technology. And I kind of figure, why not just start exploring that before that resin even exists. So then when it comes, we're just ready to start printing right away. So the title of the video is Aligner Designer. And again, I feel like that is a very true statement here. I'm going to show you how that works in Meshmixer with the aid of D3 Mesh. However, D3 Mesh is not a requirement to do this. D3 Mesh, all it does is just run, it's just a big macro tool. It just runs certain tools in order with certain parameters. And unless you're, spend a lot of time in Meshmixer and know what all these things are, it can kind of take a lot of time to figure out. So that's what D3 Mesh does, is it just automates it for you. But like I said, this can be done manually, without a doubt, and that's how I figured all this stuff out to begin with. So, without further ado, let's just get going. So, virtual vacuum former, that's the tool that we're talking about here. I just kind of thought it was a good general name for what this is. It's just something that produces shells over a surface. So, in our case, it's a dental arch, but the reality is this could be used for facial prosthetics, any other type of medical specialty where you might need to create some sort of offset appliance or device to a certain anatomical region or part. So yeah, this could be, it's multi, I truly believe it's multi discipline and multifunctional. So Again, let's just get going. I don't know why I keep on talking about that. Virtual vacuum former, that's what it is. That's the tool. And it says the first thing is import a non-manifold scan or a solid slash manifold model. So the difference between this and something like the custom tray tool up here is with the custom tray, the model that you start with actually needs to be a solid manifold model. The reason is that's what's needed for the current undercut removal algorithm that I have. It's not necessary 100%, but that's just where it's at right now. That's going to be a further implementation down the road where it doesn't need to be specifically a solid model. But in this virtual vacuum former, since we're not removing any undercuts or anything like that, we can, or actually we don't have to worry about that. So virtual vacuum former, it can be either one of the models, and press go. I think the only thing this first step does here is it just selects all the triangles or everything on the model, and then if there are any existing face groups, maybe from using some other tools before you get started here, it just removes those. So it doesn't really change anything with the model at all. It just cancels out or removes any of the existing face groups. And you'll kind of see why in just a second. So the next step here is press next to continue. Advanced users could use this opportunity to add attachments, brackets, virtually wax up teeth, virtually extract teeth, etc. Then press next. And that is very true. So like I said, if you're with this particular tool, or for those indications that can be used for this tool, you're not going to have to remove those undercuts. Again, it's going to be a common theme when I say here. So you can add brackets, clear liner attachments, different things, whatever you'd like here. And then once that's done, then you can progress to the next step, and then you can make a shell over that. So you kind of, the idea is to start with whatever model that you're going to eventually want the shell to be on. You need to get that set before you hit this next button here. So sometimes that would mean doing something like a virtual extraction. I'm going to do a different video on that and how that works. But for now, this is just kind of just showing you the aligners. So again, let's just get to it. There's some other buttons here, but we don't need any of that. We're just hitting next because all we want to do is just create a simple 8-liner or Essex style shell over this dentition. So the thought kind of is, you'll have multiple, with whatever ortho software that you use, it may produce a series of different models for you to 3D print. But then what you could do instead of doing that is you load them all into Meshmixer and you start running this this routine here, and you'll convert the models that have been exported from your ortho software, and you'll import it into D3 Mesh, and then you'll convert it into the aligner, the direct aligners instead of the models themselves. So that's kind of the thought process on that. And all this is doing right here is it's just kind of, because the next step is going to be asking you to draw the border of your appliance. And every scanner, every, whether it's intraoral, desktop, they all produce slightly different resolutions in the mesh. And all those steps that we're just going on do really is just kind of make everything like an equal plane at this point. So whatever model came in, it's now going to be about the same as far as density and quality and everything like that, and just makes things a little bit easier programmatically, to have less failures with all different types of models and things like that. So next step is draw the appliance border, left click drag, change your angle of view by using the right mouse button, and that's basically it. So the beauty of this here, and I know with aligners and retainers, S6 retainers, a lot of the time you kind of go, at least when you're trimming them from a thermoform or vacuum form workflow, you kind of just go, from gingival margin, straight line all the way across, and it's fine. It's totally fine. You could get a little bit more interproximal, but it just takes a little bit more time, and that's really, I think, the only reason. Maybe there's some strength reduction as well, as far as the actual using S6 retainers go, but I always think they look a lot nicer when you have those embrasure spaces kind of built in. Maybe you don't need them for every embrasure space, but what doing this virtually does is it allows you to control that. So I'm going to start drawing this outline here, and excuse me for any mistakes I made or if everything looks weird, but I'm just going to try to go fairly quick here. And I really do like this. It's called the Lasso Select tool in Meshmixer, because you do your little line that you need to do, and then you can rotate your model and then continue on. That's not always true with certain selection tools, so that's a nice thing to have. And then another really good thing I'll probably show you in just a second, because it will happen naturally. But if you make a mistake on, like, oh geez, you don't like that part right there and you messed it up, you can just start from back here and continue on like you were supposed to. And you know what? You see this thing right here? I should have smoothed that out before I got started. And it probably won't make a difference as far as this final result goes, but just to be safe here, I'm going to go like this. I'm going to go and again, I'm able to get a little bit higher in those embrasure spaces than typically would, I think, do on a normal manual workflow here. And you don't want and I've only found this out just from trial and error, but one thing you don't want to do is get too far into that embrasure space, because on the other side, when I come around, those two areas, if you look from the occlusal direction, if I go way far in this way and come back, and then on this side come way far in and come back, you're almost creating an intersection of those lines, and that just kind of creates problems with generating that final appliance. So I personally be a little bit careful here as far as going too far into the interproximal spaces. And again, I feel like I'm just taking too long here. See if I can hurry up just a little bit. And the other nice thing is, you know, not all these gingival margins are on the same plane, so sometimes cutting those are a little bit awkward. And by doing this, you can really get snug right around those different contours, as well as, you know, rotations of the tooth, or things like that. So I'm coming around here, done. Hopefully, good, thank God. That is our selection. That's looking pretty good. Probably should have gone down there a little bit more, but I'm okay. So over here, now that we have our selection done, how much of an impression gap or spacer do we need? For this particular indication, we do not want any impression or spacer gap. But this kind of is a little bit of a foreshadowing to the how I guess abstract the tool is, how universal the tool is. It's not just for doing this. It's not just for doing this other thing. It's for any type of shell that you can think of that will be on a dental arch. So whether you want a certain impression gap on certain places, or you don't want it, or you want perforations, or you want stops. It's kind of a very general tool that you can use for a lot of different indications. That was kind of the goal of doing this. But again, for this one, impression spacer gap, 0. Appliance tray thickness. We're talking about aligners here, so even 1 millimeter is very, very thick. And like I said, again, I don't think we have the resin to really do this, but let me get it down to maybe like 0.6 right now. I'm kind of see how that looks. I still think that's probably way too thick for aligners. I mean, if you measure like an Invisalign one, I don't think it's 0.6, but still, let's just go with that, because I think if you get too low, it might throw you some errors here. So let's just start with 0.6 for now. And this checkbox here that says enable minimal thickness, what that means is that through the steps going on past this, it'll eventually will go to a point where it ensures that the thickness of that model is a certain dimension. So it doesn't have to do that, but it can if you want it to. So I kind of decided, like, well, let's just add a checkbox there, because some resins really do want you to print with a certain minimal thickness, or it's the part quality at the end is best if it is a certain thickness, minimal thickness. So that's what this is here for, and for this particular application, I think that's a smart thing to do. So we're going to go enable strict minimal thickness. And it doesn't change that much, I mean, it's not like there's going to be areas where it's just like, 6 millimeters in one spot and, 0.5 millimeter in another. It just varies very slightly, but this is a good tool just to make sure that it's always exactly at that minimal thickness. So we're going 0.6, we're going to go next. Okay, it's getting rid of the extra part of the scan that we don't need at this point. And then our tool here is asking us add as many tissue or occlusal stops as we need. For this, we don't need any of that, so we're going to hit next. And then perforations, we don't need any right now, but one application that might make sense here would be I can make this brush a little bit smaller up here. And I know sometimes, you want to add like little, like cuts in certain areas for rubber bands and things like that. So this would be an area, or this would be the time to add those. In fact, maybe I'll try to do that right now. And I really don't treatment plan my own clear aligner therapy, so I'm not sure where these things would go. But let's just say like a nice little cut right here. All right, well, we'll see what happens. I've never tried this before, but probably a good idea to not try something right as I'm recording, but that's okay. So we'll say that is the perforation. That worked pretty good. So it's doing the offset or the extrusion, and then because that kind of creates a funky looking model, right after that it gets remeshed a little bit and smoothed. I don't know about, oh geez, this part. Oh yes, it worked. I was gonna say right here it looked a little funky. I thought it was gonna fail on me, but it didn't. So good. And like I was saying, it just kind of smooth things out, and then this part right here, it's just doing the minimal thickness. So it does generate a model without doing a make solid first. So that will always be there, but the make solid thing is really the minimal thickness. So if you see over here on the left, that says 0.6 millimeters, and that was our input before. And you might wonder, like, well, where does that, if it is less than 0.6, where does that additional thickness get made up? You know, is it more towards the intaglio or more towards the exterior? And honestly, I'm not quite sure. It probably does like a mathematical algorithm to kind of combine the two, so it doesn't affect the geometry, the accuracy of the final geometry as much as possible. But I'm not sure if it does just one or the other, but I'm pretty sure. I mean, it just makes sense that it would be some sort of like average between the two. But I guess the practical, yeah, there's that little cut there. The practical proof here would be, we did say it needed to be a minimal of 0.6, and if I press the select tool, which is S, and I have both these models up, and then I, even though this is the only one active, if I double click on this other one, and wait for a second, and then hide that other model, I can look on the intaglio here, and I can see where that model is touching the inside or the intaglio of the tray here, or the aligner, or the Essex retainer. So I mean, it looks pretty good. It looks like it's being basically, I guess those are all the the pressure points, or if you were doing aligners. So this is another way maybe you could check that too. If you were designing your own aligners, you kind of do this, place it on the model, and then see where those pressure areas are for certain orthodontic movements. But this looks very even and spread out all the way across, so I know that's fitting very intimately on that model. So there you have it. That is the fabrication of an aligner. And again, like I said, I know the resin's probably not out yet, but it's just a matter of time. I mean, it literally is. And this is what this looks like. You can kind of see in these areas here where it got just a little bit almost too close when I got interproximal, but it worked out just fine. And if you were to 3D print this, obviously if the resin supported it and you could do it thin enough, this would 3D print. In the meantime, You can kind of make this at a thickness to where you can use indirect bonding tray, and you can do the indirect bonding tray resin, excuse me, from Nextdent, and you can print these types of things out. No problem. It does have to be a thickness, I would say, of if at least 1.5 to 2 millimeters in order for that indirect bonding tray to work really good. Maybe even less than that, but for now, that's kind of my go-to on that. So that's that. There's your aligners, and here's to the future. All right, take care. Have a good night.